Okay, so new unit, everybody has, right? Sheets are up at the front there. So, timeline and worksheets. Okay, so looking at the timeline overall, what's happening in the next? So this will be tested on Tuesday, April the 21st, so 2 weeks from today. So we got a couple of weeks. Make sure you got good factoring skills by today or tomorrow, because you're going to need them. Okay, so there will be a fair amount of factoring in here, right? So you cannot escape factoring. It will hunt you down. So rational expressions, non-permissible values, and simplest form. Rational expressions. Any algebraic expression that can be expressed as the quotient, so quotient is the act of doing what? Dividing, of two polynomials is called a rational expression. In other words, rational expressions look just like fractions, except the numerator and denominators can be polynomials as well as just numbers. Some examples. So 7 over 3 is a rational expression, right? Now normally we would just call that a fraction. Might even call that an improper fraction, right? But call that a fraction. But you can also have expressions. So 3x over x minus 2, x squared minus 4 over 3, etc., right? This is in a factored form. This is not factored, but should probably be, and we will be doing that in order to simplify this expression. These are not factored, but should probably be factored in order to do this kind, simplest form, and so on, right? All right. That's that for that page. Non-permissible values. So if you have a rational expression, sometimes you got problem. Wow. I don't know what happened there. Something blinked. Rational expressions can be evaluated at different values of the variable. What is the value of 3x over x minus 2 at x equals 4? So how would we do this? What would we have to do? Substitute x equals 4, right? So we would say, one of these. Right quick, it's going to disappear. Okay, so we can evaluate this. That must have been the whole blinking lights thing. I'm just going to wait. It'll come back. Well, this will disappear and then it'll come back. So we can evaluate this by substituting x is equal to 4 and then evaluate it, right? Work it out. And we get 6. What is the value of 3x over x minus 2 at x equals 2? Okay, so same deal, right? What do we get? There we go. Now we've got the heavy-duty line. Go back. So what's 6 divided by 0? What can't you do? You cannot divide by 0. Right? Think about what division is, right? Division is how many of these are there, right? So like 12 divided by 2. How many groups of 2 are there in 12 items, right? So we're taking 12 and dividing it into groups of 2. Well, there's 6 groups of 2. How many groups of 0 are there in 6 items? I can't do that, right? I can't pull zeros out of there, right? I mean, 6 divided by 1 I can do, right? 6 divided by 2 I can do. 6 divided by 3 I can do. 6 divided by 4 I can do as long as I can split objects up, right? But so some rational expressions are not defined at particular values. In particular, rational expressions are not defined at any value that makes the denominator equal to. Say, I draw attention on this cat. Wait, 0. Thank you. Not going to take a step until you answer. Since substituting 2 into 3x over x minus 2 causes the denominator to be 0, we say that 3x over x minus 2 is not defined at x equals 2, and that 2 is a non-permissible value, which will often be abbreviated as NPV. At least I'm often going to abbreviate it as NPV, because writing out non-permissible value all the time. of 3x over x minus 2. A non-permissible value, so here's the definition, right? Drum roll. A non-permissible value of a rational expression is any value that makes the denominator equal to 0. Right? So you want to figure out non-permissible values. You take the denominator, you set it equal to 0, you solve for the variable. That's how you get That's how you get non-permissible values. Okay, questions? Straightforward, right? To find the non-permissible values of a rational expression, you must determine all the values. Again, I saw that, right? It'd be a thin line, right? All right, just talk slowly. Wait till the line disappears. Something up there. I don't know why. Maybe if I put this back in. Nope. All right. To find, hey YouTube, I don't know what's up. To find the non-permissible values of a rational expression, determine all the values that make the denominator equal to. What does yours say? Okay. Well, I don't know. Let's make that a 0, right? That's going to disappear. Task of what? Does yours say this? Oh, the task. Why? Equal to 0, so like period the? It. Okay, glad yours is good. The task of finding non-permissible values can be asked in several ways. For what values of the variable is each rational expression not defined or undefined? State the non-permissible values. Usually it's state, right? I mean, you don't have to show any work, it's just what are they. State the restrictions on the variables, right? Now there's a subtle difference between non-permissible values and restrictions, okay? We'll get into that. I'm not really going to distinguish between it too much on a test, like when you're writing stuff out. If I ask for restrictions and you give me non-permissible values, it's like, yeah, it's okay. If I ask for non-permissible values, you give restrictions, yeah, it's okay, right? It's just there's this very minor difference, but we'll get that down in a minute. Stuff disappeared yet? Yeah. 0. Okay. For each rational expression, determine the non-permissible value. So determine means show your work, and here's the place for the work. That is, determine the value, I should say value, or values of x. Although maybe it is just value. No, it's values. Determine the value or values of x that makes the denominator, there should be make or makes, the denominator equal to 0. Where necessary, express all non-permissible values as improper fractions, right? We like our fractions improper. All right, -2 over 5x. So what's the work? What do we say? We say, so we take the denominator and we set it equal to 0 and we solve for the variable. So what's x? 0. Non-permissible value, x equals 0. Right? Easy. Now your turn. Do the rest. I'm going to pause. Now, when you get something like 4x minus 3 equals 0, there's an easy way to do that, but let's do the detailed way. So the detailed way is, all right, I'm going to add 3 to both sides, and then I'm going to divide both sides by 4. Okay? Now, the easy way to do that is you take this number here, and you change its sign, and you put it over this number here. So that's -2 becomes positive 3 over 4. Reason? When you move this to the right-hand side, it changes sign. And then you divide by this. So I look at 3x plus 2 equals 0. And here, all right, wait, that's 3/4. So x is equal to, change the sign, -2 over 3. Now I'm going to show the work because it said work, right? So 3x is equal to -2. X is -2/3. Okay, we're not going to ask you for the work, so you look at something like this, you can just go x is equal to 1/6 or -5. And here, 6x minus 1 equals 0, 6x equals 1, x is 1/6, x plus 5 equals 0, x is -5. Doesn't matter what order you state them in. I should have gone the negative one first and then the positive, but there's only two of them, so it's not like a big deal. Here, now we still have two terms, right? I got 2x, so what value of x makes 2x equal to 0? Well, if x is 0, the whole denominator is going to become 0, right? So x is equal to 0, or negative 7, change the sign, make it 7, divided by 3. The work, 3x minus 7 is equal to 0. 3x equals 7. X equals 7 over 3. Now, I don't care if you're using scrap paper and doing this on your scrap paper. Well, I do. I don't like you to use scrap paper. I'd rather you squeezed it in, you know, with the solution. Because I think if it's all in one place with the question, then, you know, when you get it back to look at least it's all there, right? It's not sort of jammed onto a piece of scrap somewhere randomly written. If you are going to use scrap paper, then I think what you should do is put down that this is multiple choice number 3, that here's where I'm doing the work for this particular question, right? Because you're going to get your multiple choice numeric back to C, but not to keep. So if you get it back to C and you did work on scrap paper and it's just a random piece of scrap paper, then you're never going to find it, right? You're going to be looking all over and it's actually sideways, written upside down somewhere in a far corner, right? So if you're actually going to use scrap paper, then write down, this is multiple choice number 3, here's my work, draw a line, do the next question, okay? I would rather you squeezed it in on the page with it, but, you know, whatever. By inspection, here we go, inspection, state. So state, you don't have to show work, right? This is where we're going, right? We just want to say, okay, hey, what are the values or values? Value or values? Oh, great. Thin line again. Thin line. Just move the thing. Oh, now it's just, you just do it. Okay, I'm going to pause. Remember the deal here, right? Take the 3, make it negative, divide by 5. Take the 2, what is this, t? Take the 2, make it positive, divide by 3. Take the 1, make it negative, divide by 5. No, it's an x. Watch your variables too, right? Like this is so. All right, so that's the whole inspection thing, right? It should not take a whole lot of thought. Okay, so just practice it until you can get it right. And always check your answers before you move on, okay? Because if you're getting something wrong, you do not want to reinforce the wrong way of doing something, okay? Not a good strategy. All right, any questions on this page, which I shall scroll up. So if everybody's watching on video, they could pause and move through. I'm messing with people. Right, nobody's ever going to watch this thing. You see some of my videos like 0 views 2 years later. Did it again. What is it? It's with you guys only. I did 30 dash, sorry, math 31. No problem. Yeah, I know, but why on, it doesn't do it on the, I don't know. Write a rational expression with, write a rational expression with the following restriction. So x can't be 0, so what do I need? I need an x by itself on the bottom, right? What do I need up top? Anything you want, okay? 7 over x. 2x squared minus 12x plus 32 over x. Okay? What's important? There must be an x by itself, or, you know, having seen those and then they disappear, right? So, is this work? Does that work? No. Does that work? Yeah. Okay. Now, if the only restriction is that x can't be 0, then I really can't do that x minus 3 thing, right? So, you know, keep it simple. All right. Like, don't get too fancy, because I think if you do go and throw an x minus 3 in there, it's like, really? Like, I don't know. Okay. T cannot equal 5. Okay. Now, wait. There's something else going on here. X cannot equal 0. When it's a restriction, we say that the variable cannot equal. When it's a non-permissible value, we say that it is equal. Okay, so if I went back here, God, why? I thought as soon as I went back, it's like, why did I do that? Right? If we go back, it's all just going to disappear. So if I say restriction, this becomes x is not equal to 0. X is not equal to 0. Y is not equal to 0. M is not equal to -4. Okay? So non-permissible value says this is the value of x that is going to make, right? If m is -4, that is going to make this 0. The restriction is I can't make m -4, right? M cannot be equal to -4 because if it is, what happens? We divide by 0. You can't do that. You can't do this either, apparently. All right, so let me just refill. So the restriction is cannot equal. That's the difference between non-permissible value and restriction, is that the non-permissible value is the value, it's equal. That's the value you want, which makes the denominator 0, and the restriction is that is the value that I cannot have, right? I cannot have. A cannot be 5. Y cannot be -3/5. T is not equal to 2/3 or -1/5, and some stray mark. And x cannot be 0 or -7/6. Okay? So those are restrictions. If it's a restriction, I hesitate to go for it. I knew that was there. All right, try and fill this in. I'm just going to wait. I'm going to pause. There is no right numerator, right? You can put anything you want up here. But the denominator has to be t cannot equal 5. So here's a way to do that, right? Well, let's do the next one. How do I do y cannot equal -3/4? So here's what I do. I say I want y to be -3/4. Which means that 4y is equal to -3, which means that 4y plus 3 is equal to 0. So that's what goes down here. 4y, I need an expression which, when I substitute the value -3/4 into it, I get 0. So how do I work that out? I say y equals -3/4. Multiply both sides by 4. 4y equals -3. Add 3 to both sides. 4y plus 3 is 0. Think about it. What's the restriction? Well, make that negative and put it over 4, right? So -3 over 4. Backs up, becomes 4y plus. What goes up top? Anything, right? Or 2. What goes on the bottom?
X minus 5, X
X.
2.
Well, plus 2.
Yeah.
Goes up top. Okay. So if I'm asking you to write an expression, what am I marking? Just the denominator, right? Now, I mean, if the numerator is blank, then we're going to have a little chat, right? So we could like circle around there and go, what's up there, right? What's up with that? Okay, so I need an m. I need an m minus 4. And what else do I need? 3m plus 1. Okay, so the only difficult one there is the m is -1/3, right? So just do this. M is -1/3. 3m is -1. 3m plus 1 is 0. I want an expression which will evaluate to 0 when m is -1/3. That is the expression, right? 3m plus 1. Do not write this. M plus 1/3. Okay, don't do that. You can do that over here and then say, better multiply everything through by 3. That's what we want, okay? Questions? Comments? Concerns? Simplifying rational expression. Functions come in many equivalent forms. Oh, sorry, fractions. It's a late off the board. I can't. For instance, 10 over 20 is 4 over 8, or it's 3 over 6, or it's, oh, again. Well, at least that happened fast. 3 over 6, I'm thinking 3 over 6, or 1 over 2. For this set of equivalent fractions, right? And when you see the word fraction, you can write rational expression. For this set of equivalent fractions, we say that 1/2 is the fraction that is in simplest form since it is reduced to lowest terms. Likewise, rational expressions that appear to be different may in fact be equivalent. This is a big deal when you're looking for the answer, right? And you have something written that is different from the possible answers in a multiple choice question. You're saying, well, do I have something that's the same as one of these? So to simplify a fraction, we divide numerator and denominator by their greatest common factor, right? What's the biggest number that goes into 10 and 20? It's 10. 10 divided by 10 is 1. So we write this as 10 times 1 over 10 times 2. So that's the GCF, greatest common factor. Then we cancel. Right? When you cancel, you write a 1, right? It simplifies, you write a 1. Another example is 24x squared y cubed over 18x to the 5th. So I want the greatest common factor. What's the biggest number that goes into both 24 and 18? 6. So put a 6 and a 6. Now, they share x's. So the greatest common factor is the lowest power of x, which is x squared. They share y's. Okay, so it's going to be y to the power of 1. So when you're doing greatest common factor, numbers are numbers, you should be able to figure that one out, right? When you're doing variables, it's the lowest power is the one that you're going to factor out, right? It's come in handy, especially in Math 31. There's a lot of that going on. Okay, so it's still factored. Yeah, you know, the ultimate course still has a lot of factoring in. Okay, so then we say, well, what's left, right? So first of all, when you factor, what should you do? Check. Okay, 6 times 4 is 24, x squared, y cubed. 24x squared, y cubed. 6 times 3 is 18, x to the 5th, y. Yep. What's the big thing? You want to make sure that these guys are, we're going to use a fancy word here, right? They're mutually prime. Mutually prime means they have no common factor, right? So they're mutually prime. There is no common factor left here. If this was a y cubed and that was a y down there, you'd say, oh wait, there's still a common factor of y, right? So we want to take out the greatest common factor. Then what? Then we cross that off and say, well, it's a 1, and we're left with 4y squared over 3x cubed. We will simplify. Let's make a new word. Simplify. I got to submit that. I'm going to look it up on Urban Dictionary, see if it exists, and if not, come up with the definition and submit it. Simplify. We will simplify rational expressions using the same method. In the table below, each row contains a rational expression that is not in simplified form. Express each rational expression in its factored form. Then the restrictions. So the restrictions come from the factored form. Okay, so order that we do stuff with rationals is always thus. Factor pretty much everything that you can. At the very least, factor the denominator, right? This is always going to be true. Rational expressions, you're always going to factor the denominator. You are then going to state the restrictions or the non-permissible values, depending on where it asks. Restrictions is not equal to, non-permissible value is equal to. Okay, so first step. Factor. Now, often we're going to factor the denominator. If you're simplifying, you're going to factor both numerator and denominator. What you do is this, right? Here's how you can do this easily. Pick the simplest expression, which is obviously 5x minus 10, and factor it. And then say, I will bet, dollars to donuts, that x minus 2 is also going to be in the denominator because these guys are going to cancel, so it'll simplify. Then, here's how you factor without factoring. Right? Pay attention, that bonus could come in here. Yo, gentlemen, watch this, not that. Watch this later. All right. Okay. Key point, right? I'm not that many times during the year. I'm not going to say, hey, pay attention. You need to see this. Okay. So this is how you, because sometimes your factoring skills need some work, but this is how you can do, right? So take the simpler expression, factor it, and then say, I will bet you that this factor appears down here. Here's how you factor without factoring. You then write this down and you say, how do I get 2x squared? Well, if I have an x there, I put a 2x there. How do I get positive 6? Well, if I have a negative 2 there, I put a negative 3 there. Then what do? Then you check this and make sure, right? Because maybe that isn't really what's going to happen, but in this case it is. So we get 2x squared minus 4 minus 3 is minus 7 plus 6. Okay? Now you see what I mean when we do the other ones. Okay, then you state the restriction. So what value of x makes this 0? 3 over 2. What value of x makes this 0? 2. Then you simplify. Simplified form is now you take out any common factor, top and bottom. Do that with a little line through it, and you replace it with the number 1. Right? Now the reason you do that is, well, that should be a little cleaner. The reason you do that, if there's no number here, like a 5, then you need to make sure that if that canceled out, that you have a 1 up top. Right? You're not going to leave the top blank. You're going to put blank over something. All right, so next one. What's easier to factor? X squared minus x minus 6 or x squared minus 4x plus 3?
X squared minus x minus 6.
Yeah, okay. I mean, there could be a difference of opinion here, but... Okay, so factor it. What do you get?
X plus 2, x minus 3.
X plus 2, x minus 3. Okay, check that. X squared minus 3 plus 2 is minus 1 minus 6. Okay, now, one of those guys is going to be on the bottom. Which one? Okay, can't be the x plus 2, right? Because there's no way to get a 3 out of a 2. So I'm going to have an x minus 3. If x minus 3 is the factor, then how do I get an x squared? What has to go here? X. How do I get negative 3 times what is going to give me positive 3? Minus 1. So did I factor? No. I just said if x minus 3 is the common factor, which I'm going to bet it is, then x minus 1 is the other factor, and now I'm going to check. X squared minus 3 minus 1 is minus 4 plus 3, right? Or you can just straight factor it, right? If you got good factoring skills, just say, I can factor either of those. It doesn't matter. One's not more difficult than the other. What can't x be? 1 or 3. What's the simplified form? X plus 2 over x minus 1. You will never, ever, 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 ever cancel an x out of a binomial. Right? And so, hey, there's an x there and an x there. I'm just going to cross them off and write that as 2 over negative 1. Right? That's just wrong. Okay. And the reason is that's not an x. It's an x plus 2. If x is 10, that's a 12. Right? And then the bottom is a 9. If that's 17, then it's 19 over 60. Right? And they're obviously not 2. Okay. So you can't cancel. Except in the next one where you can. Okay, 5x squared. There's nothing to factor there, right? How do we factor x squared plus 3x? What's the common factor? X. What's left? Okay. Step 1, factor numerator denominator. Step 2, from the factored form, state the restrictions. What can't x be? 0 or negative 3. Right? I'm finally going to do it in the order I have to go from low to high. Doesn't matter. I don't care, right? Just write them both down. Don't write any extra ones. Not that in this case there would be anything extra. I mean, up here, you might go and say, oh, x can't be negative 2. Why not? Because the numerator can be 0. What's 0 divided by anything? 0. Right? How many groups of 2 there are in nothing? There are no groups of 2. Okay, then what? Well, cross off the x. take out the squared. Okay, what are we left with? 5x over x plus 3, right? When we're simplifying, what we're basically saying is this expression here is equivalent to this expression here, right? It's for any value of x. So if x is 10, what do you want to work out? This or this? I think I'd rather go, hey, 12 over 9 and then reduce that than I would go, okay, 100 minus 10 is 90, minus 6 is 84, and 100 minus 40 is 60, plus 3 is 63, so it's 84 over 63. Oh, but wait, they both have a 7 in them, right? So that's 12 over 9. Oh, wait, but we can get 12 over 9 from this and then reduce it. Okay, so it's saying this expression is the exact same as this as long as what? So this, same as this, as long as x is not equal to 1 or x is not equal to 3. Now, you can put a 3 in here, right? Anything wrong with putting a 3 in there? 5 over 2. But you can't use 3 because in the original, you can't put a 3 in there, right? You end up with, what's 3 give us? 9 minus 6 minus, you get 0 over 0. Yeah, all right, but you can't have a value that makes the denominator. So it's like here, right? Can I put a 0 in there? Sure, I'll get 0 over 3. But can I put a 0 in here? No, I'll get 0 over 0. Again, undefined, right? Can't divide by 0. All right, 6x minus 3. Does that factor?
Yes.
What's it factor? What's the easier one to factor, top or bottom? Top. Okay, what's the factored form? 3. Okay, now the bottom's really not that hard, right? It's just a difference of squares, one of which is 2x minus 1, and the other of which is 2x plus 1. First you factor, then what do? Check. First you factor, then you check. Because if your factoring's wrong, then, I mean, in grade 10, if your factoring is wrong, it's like, oh, there's a little x and you lost a mark or whatever, right? If your factoring's wrong here, now your simplified form is wrong. Okay, well, that could be bad. But then I'm graphing that simplified form. Okay, well, that's wrong. But I'm using that simplified form to do something else in calculus. Well, guess what? You factored wrong, so everything from that point, which could now be a page or two worth of work, is wrong. So it's worth spending a moment to check, right? Just go back through. 6x minus 3, right? What do you usually mess up? If you're going to mess up factoring, what do you mess up? The numbers or the signs? Usually it's the signs, right? Most people can sort of figure out two numbers that multiply to 3. Okay? But maybe they get the signs wrong, so you got a plus and a minus. That's why we just run a very quick check. How long does it take to check a factoring? Right? Like 5 seconds. Okay, 10 if you're slow. What are the non-permissible values? Okay, so negative a half and a half. How are we going to write that? Just say plus or minus 1/2, right? Okay, plus or minus 1/2. Simplified form is? What's up top? What's left?
3.
It's on the bottom. Right. Okay. So those are equivalent rational expressions. Not only that, but that one is in simplified form, right? Because there's nothing, I can't do anything with 3 over 2x plus 1. There are no common factors top or bottom. All right, now it gets messy. What's easier to factor, the top or the bottom? Seriously? Which, are we looking at the same one?
You just take out negative.
We're doing this one. So what's the common factor? Take out a negative 2x. What's left? 3x plus 2. What are you going to get wrong? Your sign. You're going to write a minus there, right? That's going to be wrong, and you'll figure that out when you go negative 6x, and if you had a minus there, you go plus, and you go oops, and then you would change the plus to a minus, right? Which is why you have a good eraser on hand when you do math, and you don't use a pen. Okay. Now, what am I betting? So one of the factors of the denominator must be 3x plus 2. 3x plus 2. Okay, how do I get a 3x squared? What goes here? X. How do I get a negative 6? What goes here? Did I factor that bottom term? No. I said if it factors, and if one of the factors is 3x plus 2, then the other factor is x minus 3. That's all I said. Okay, 3x squared. Minus 9 plus 2 is minus 7 minus 6. All right, so after we factor, we check. Non-permissible values. This one? This one? 3. What about this? Why x is 0? Isn't that a restriction? X can't be 0? It's not in the denominator, right? Who cares? If x is 0, so what? You get 0 divided by negative 6. What's 0 divided by negative 6? 0. It's not undefined, right? What are we looking for? Values of x that give us this expression being undefined. How does that happen? One of these guys is 0. Don't care about these guys. In this case, seeing as there's going to be cancellation, that could be a 0, but we don't care. And the final form is? Negative 2x over x minus 3. You may also see this written as, just selected everything. Are these the same? I hope so. It would be really embarrassing to have written that out. I said, no, it's not quite the same. Are those the same? Yeah, so if we multiply the top and the bottom by negative 1, what happens? Well, we get a positive 2x, and on the bottom we get negative x plus 3. You usually don't want to lead with a negative, especially if you got a positive, so 3 minus x. So these are the same. Maybe this is what you see in the this is what you get, and then you look for it in the multiple choice, and it's not there. And you just go, I got it wrong. My life sucks. And so you got to say, wait a sec. Maybe I have the correct answer in a different form, right? And that is, oh, okay, what happens if that's a positive 2x? This becomes a 3 minus x. Oh, there's the answer. Okay, good. All right, you do the last one. I think it's probably easier to factor the denominator, right? So what goes in? Okay. Therefore, one of the factors of the numerator must be what? Okay, now, there's no guarantee that it is, right? I'm just saying if things are going to cancel, then it is. If it is, then what's the other factor? X plus 3. Now what do we do? 2x squared plus 6 minus 5 is plus 1 minus 15. Okay, now we go on. So we say x cannot equal 0 or 5 over 2. Remember, don't use 2.5, right? So when you're expressing restrictions or non-permissible values, improper fractions, okay? 5 over 2, not 2.5. And what do we get? What's left? X plus 3 over 4x squared, right? So restrictions must be stated. We generally don't determine them, we state them. And they could be non-permissible values, in which case we have what instead of what? We have an equal sign instead of a not equal, okay? So restrictions or non-permissible values must be stated from what? Or when? When do we state them? After we do and before we, so after we factor and before we simplify or cancel, right? So after we factor, before we cross, don't cross this off and then, oh, x can't be 0. Right? You do it before you simplify, okay? After you factor, so step 1, factor everything. If you're simplifying, factor the numerator, factor the denominator. Step 2, state the restrictions. Step 3, simplify. Write the 3 steps. Oh, well.
Yeah.
Dang. Seriously, I never even looked at this. All right, so step one, what do we do? Factor. Oh, really? Still? All right. Okay, so to simplify rational expression, factor the numerator. I'm going to wait. There's no point in continuing to write. Factor the numerator and the denominator. Step two, state the restrictions. Where are they? From the factored form of the denominator. Okay? So step one, factor the numerator and the denominator. Step two, state the restrictions from the factored form of the denominator. Step three, simplify by canceling common factors. So factor, to reiterate, repetition is good, right? Factor the numerator and denominator. Anything to do with rational expressions, if I remember correctly this unit, factoring the denominator will never put you on the wrong path. There are times where we don't want to factor the numerator right away or at all, right? But those times will not be coming for a couple of days. So for now, factor the numerator and the denominator, okay? We will always factor the denominator. No matter what we're doing in this unit, we will always factor the denominator. We will then state the restrictions, restrictions from the factored form of the what? Denominator. Only the denominator, right? We don't care about the numerator. From the factored form of the denominator, and then cancel common factors. And that leads to the simplified form. And the last thing you can do is just check. Just look at your simplified form and say, hey, they're both even. Well, I got a 2x plus 4 on the top, and I got a 2x minus 10 on the bottom. I need to factor out a 2 and cancel it, right? So make sure there are no common factors left. Okay? So simplified form, and then I'm just going to say check. So factor the numerator and denominator, then check them. Okay, question? Oh, I should move ahead. Yeah. Why? Simplify each of the following rational expressions and state the value or values for which the rational expression is not defined, that is, state the restrictions. Okay, so having defined what a non-permissible value is, we're not going to use that anymore. It's all going to be about restrictions, right? So pretty much you're always going to write x is not equal to. Right? But if you get a multiple choice question that says the non-permissible values are, you're just going to see x equals. Right? Just don't let it throw you. Okay, so factor. Do we factor anything here? Nothing to factor. Well, there is something to factor. What can I factor? What's common? So 6. Okay, so I got a 6. What else? Got an m, lowest power, right? Here we go. 6 m n2. And what do we get up here? So we get negative m on the bottom. Now, you know what? I would rather actually just take the negative out as a factor. So let's do that. Negative 6 m n2 times m squared. Bottom. Okay, well, a 6, right? Because we need something to cancel. I mean, 48 you could take out a 12, but that won't help you. So you take out a 6. Okay, an m and an n2. Okay, so what's left? How do I get 48? Need an 8. How do I get m? Already got the m. Don't need that. How do I get n to the 5th? N to the 3rd. Okay, state the restrictions. m cannot be, and neither can n. So m can't be 0 and n can't be 0, right? If m is 0, whole denominator just becomes 0.
Can't you make them both 6mn squared and then just cancel them out to simplify it?
Okay, didn't we sort of do that?
That's what I did. I had negative m squared over 8n to the
Well, okay, so now I'm going to cross this off. Cross this off. I'm left with negative m squared over 8n cubed.
Oh,
It's all where you get your negative from, right? Okay, next one. So what do we get? Factor, right? 6, 5. Restriction? Just 2. How do you get 0?
5.
Yeah, there's no x by itself, right? Okay, so what's the answer? 6/5. As long as... Yeah, so this is the same as this. Always. Unless x is 2, in which case this is 6/5 and this is undefined. Okay, factor. Alright, so I think this one's easy to factor. And this is not going to have an x plus 5. I can kind of see that, right? So what do we get? 6x. What are the restrictions? Okay, now you can have a 0, right? 0 and negative 2. And what's your answer? There it is there. The exception to the rule. Right? And I didn't write the x plus 5 on the bottom, right? Because it's saying, oh, there's going to be a common factor. Nah, there's no common factor here. Okay. Well, there is, but it's just the 3, right? The only thing that simplifies out is the 3. Any questions on that one? Okay. So that one, there was no point writing an x plus 5 and then saying, oh, and the other factor, yeah, no, I don't have an x plus 5. It's not a factor. Yeah, look, surprise. Okay. What's easiest to factor? Numerator or denominator? Numerator, yeah. Okay. You know the drill. I'm just waiting for the equal sign to disappear. Okay. So we must factor the numerator. Then we factor the denominator, which we do, you know, like you really don't need to factor the numerator to do the denominator. Okay, still waiting for the equal sign to disappear. Should move ahead. I should just go to the next page now. Still waiting. All right, I'll start. All right, if I have this, then I have this, x squared, yeah. Okay, 2x minus 4. I'm betting there's an x minus 4, which means this is x plus 2. X squared minus 4 plus 2 is minus 2. Yep. State my restrictions. Negative 2 and 4 cancel. All right. What's easier to factor, numerator or denominator? Denominator, right? Just difference of squares. 2x plus 5y, 2x minus 5y. So one of these, which one? It's kind of obvious. It's got to be the plus. Why? Because the top has positive, positive, right? So you know, if the top had a negative, then it could have been either one. Right? Could be positive, could be negative. Don't know. But in this case, do know, right? It's got to be 2x plus 5y. Okay, if it is, what do we get? X plus y. 2x squared plus 2 plus 5 is 7. Yeah, okay. Well, let's do it. Right? I mean, it's not like, if you're good at factoring, it really doesn't matter. You don't have to do this sort of fake factoring thing, right? Let's call it faux factoring. I mean, It's a little fancier, right? It's not fake, it's faux. And not in the terms of the noodle soup either. Yeah, when you're stating restrictions, right, it's like 2x plus 5y can't be 0. You know, and it's 2x minus 5y. So if I'm doing restrictions, I'm probably going to leave them like this. I mean, you could write it as, you know, you could solve those. Okay, so then what do we get? 2x is not equal to negative 5y, and x, well, it's just going to be plus or minus 5 halves y. So x cannot be plus or minus 5 halves y. All right, we're not going to go too, yeah, I'm not too terribly worried about, you know, I think this is probably good enough. Just saying 2x plus 5y can't be 0 and 2x minus 5y can't be 0, right? Like I know that this, neither this nor this should be 0. I think that's good enough. Right? And these guys cross off, and we're left with x plus y over 2x minus 5y. Why did I keep a period? It's always there. Do it. Yeah, okay. Yeah, okay, it works. So I'll often list my restrictions up top, especially on this, because I just don't have room. Okay, so as long as I can see the restrictions. Okay, and we're done. So is that right? I did mess up something this morning. Oh, I gotta change the video for this morning, not for you guys. Somebody didn't speak up in time. He says, I did. I said, well, you weren't emphatic enough. I could have fixed it. It should be a W shape. All right, we good? Is there more? Is there much more? 3 more. Oh wow. Obviously, they're very they're very separated on at least on this. I don't know on your page. Not so much.
They're the same as the other.
Yeah. Okay. So I'm gonna. Really? All right. Well, that's a difference of squares, right? So at this point, I'm not really sure. I'm gonna go with, hey, let's try x plus 3 just because. And then this will be 2x minus 7. That's a real guess. Like I have no idea, right? So it's 2x squared minus 7 plus 6. Like sign's wrong. All right. So it's going to be 2x minus 7, and then it's going to be x plus 3.
We just tried.
No, it's going to be 2x plus 7. Yeah, we said 2x plus 7 and x minus 3. Ooh, and there's special stuff that's going to happen here, right? Besides the disappearing act. All right, tell you what I'm going to do. I'm going to flip this on its head. Okay, I'm going to factor a -1 out because at some point I have to. All right, I'm going to do this, then I'll back up and go back to what I had before, which if you were watching and saw, you saw, and it disappeared, and you can always, but I'll do it again. So negative, so let's go x plus 3, x minus 3. Okay, I'm going to write x minus 3 just because that's really easy to change to a plus if I have to change it. And then I got a 2x and I got a 7. I'm not really sure of the sign. So that'll be a plus. So we'll get 2x squared minus 6 plus 7 is plus. Okay, so that's going to work like this, right? If that didn't work, I'd change that to an x plus 3, and then it'd be 2x minus 7, and then I would check it. Okay, so this cancel. Oh, wait, no, restrictions. So x cannot equal -7 2's or 3. Okay, then we cross these guys off. Negative x plus 3 over 2x plus 7. Okay? Negative. Could be x plus 3 over negative 2x minus 7. That'd be really ugly, right? Because you just have the two negatives there. Could be x plus 3 over the negative and then bracket 2x plus 7. Again, they're all equivalent. Okay, now let's back up and do it differently. Now, you only need to do one of these, obviously, right? So let's say you just wrote, all right, it's 3 minus x, 3 plus x. And you go down here. Now, at this point, you know what? You're better off just factoring this. Okay, there's got to be a 3 here, right? Now, I don't know if it's 3 plus x or minus x, so we're going to go with, I need a plus and I need a minus. So 2x squared minus 6 plus 7, yeah, minus 20, okay. So here's the problem, right? Well, okay, wait, first restriction. Negative 7 halves and 3, okay? Always restriction. Now, if it doesn't say that you have to state the restrictions, at the very least you need to keep them in mind, because eventually on this pink sheet somewhere it's going to say solving rational equations, right? Where, yes, see, solving rational equation, and it's like 2 days worth. So when we solve a rational equation, sometimes the act of simplifying, which we're about to do here by doing a little bit of magic, will give us a solution which is one of the restrictions. So we must always know the restrictions, right? Because sometimes we have to reject a solution because it's a restriction. All right, so I get x minus 3 here and a 3 minus x. What do I do? Here's what I do. You and you are gone, but you're going to be replaced with a negative 1. All right? Now, wait, watch this in slow motion.
Why?
Why? So, 3 minus x, oh, sorry, 3 plus x. What was it, 2x plus 7? Okay, so here's what happened in slow motion. Factored a negative 1 out of this. Why? Because it'll flip the signs of what's in here. So what do I notice about these guys? Hey, they're the same, but they have opposite signs, right? X is negative, 3 is positive. X is positive, 3 is negative. Stick a negative out there, flip the signs. It becomes minus 3 plus x, right? Which is x minus 3. Which now is this guy. And these guys cancel off now. Okay? So you don't have to do this, right? If you look at it and you say, hey, same two terms, opposite signs, I'm going to cancel them, but I'm going to replace one of them with a negative 1 and the other with a positive 1. Okay? And this is why. Okay, then let's flip this around, just write it as x plus 3. You know, addition, the order doesn't matter. Okay, keeping in mind that we do have those restrictions. Okay?
Should there be a negative?
And there should be a negative in front of the x plus 3. Okay? Thank you. Good. I hate to go back and have to throw another text box in today. Once is enough. All right. So we learned something, right? Which is, hey, let's do this. Oh, God. Right? I'd rather factor a difference of squares that looks nice. And by looks nice, I mean the variable that's being squared, that should be positive.
So why isn't it?
Well, it is now.
It's
Yeah, it's
Shouldn't
still
it
a
be positive
negative.
inside the bracket, though? Oh, you just flipped it. We're still
Why is that a 3 in that? Really? It's the same question you guys got?
Yes.
Yeah.
Really?
They just made it really
X
complicated.
squared
Well, they made it complicated and nothing cancels. Well, maybe something did. All right, now that it's canceled itself. All right, well, let's see where it goes. I'm looking at this and just saying, you know. Okay. Let A equal x minus 3, a squared plus 7a plus 6, a plus 6, a plus 1, yeah, good enough. Okay, so what do we got? X minus 3 plus 6, x minus 3 plus 1, and that. Okay, now we're ready. X squared plus 4, x squared minus 4, x plus 3, x minus 2.
Wouldn't that be plus 2 because
Now I can do my restrictions, right? So I need this factored form. So what can't x be? Negative 3 or 2, right? All right, is that it? We're done? Oh, wait. That factors, right? It's a difference of squares. So always watch out when you got an x to the fourth. Negative x squared plus 4, x plus 2, x minus 2, over x plus 3, x minus 2, equals, that's why this is on its own page, negative all right, now I see, yeah, it worked. I was worried initially.
Are we gonna have ones like that on the test?
Yes.
oh my god.
Well, why not?
Why
Right.
not?
Okay, so, well, okay, look. It's just a lot of factoring, right? You know, this is something we expect from you. I expect to be able to factor that, right? You know, I did it over here. I went over to my scratch paper there and just, you know, sort of sketched it out and then said, okay, really, here's what it is. Okay, and then here it is simplified. And now, from here, that's when I do these guys. Okay, now what? Oh, wait, that's still a difference of squares. So it's just a lot of factoring, but there's nothing, you know, nothing beyond the realm. I'm just going to say, yeah, you could see that on a test so that I don't have to come back to later and say, remember when I said no, you wouldn't see it? Well, maybe you will. So maybe you will. Just like this. Maybe you will. Oh, God. All right, so off to the side there, is this the last one? Yeah, oh, thank God. So off to the side there, I'm just going to write 2a squared plus 5a minus 3, and I'm going to factor it. And the top probably factors relatively easily. And I'll just pause now, because, God, it's been forever. Okay, here's little scratchy stuff here, right? I got 2 plus 6 minus 1 is plus 5. All right, so 2x, x, 3, 1. 3's got to go here, 1's got to go here. This is minus, this is plus. And that works. Okay, and we've got 2. Now, from over there, minus 1. And we've got plus 3. Okay, so 2x minus 3. Can't do the restrictions yet because I don't have factored form. So I'm going to do this all at once, right? It's 2x minus 2 minus 1, which is 2x minus 3. Hey, something's going to cancel. And this is x minus 1 plus 3, which is x plus 2. Okay, now I can do my restrictions. 3 halves, negative 2, cancel, and answer. Okay, now somebody verify that before I say done, and then can't go back and fix any mistakes. Or can't easily go back and fix mistakes. And this is what Math 30-1 is like every day. Seriously, you got any friends in 3-1 say, how long do the lessons go? Say, how long don't they go? They go all class, and then you have to go home and work. Now I need a definition for simplify. Simplifying the symptoms. Okay, is it right? Come on, somebody? Anybody?
Yes.
Yes? Thank you. All right. And so, in less than, in 1 hour and 5 minutes, just over